In this video, I will demonstrate how to solve previously administered AP Calculus ABBC multiple choice questions using the box rules. With some practice, you'll be able to find the answers very easily and impress your friends with lightning-fast problem-solving skills. For those unfamiliar with the box rule for integration or unsure its application, please watch the video in the upper right corner. The video will show you how to solve integration problems in just one or two lines without use substitution. We have our first problem here. Let's try to solve it easily using the basic box rule on the right hand side. First, if you bring the terms in the denominator up to the numerator, we get 1 plus x to the power of negative half. Now let's think about what to put in the green box and the box prime. The 1 plus x highlighted in green should go in the green box below, and its exponent will, of course, be negative 1 half. The differentiated term of the 1 plus x is just 1, so let's put that in the box prime. Then we copy and paste the terms in the left green box into the right green box. Add 1 to the exponent to make it negative 1 half plus 1, and copy the same value to the denominator. Now we need to evaluate the integral by plugging the values. If we simplify the expression a bit, we get 2 times square root 1 plus x. And if we plug in 8 and 0 to the expression and subtract, we get 6 minus 2 equals 4. Therefore, the answer is D. This example has a square root. If you can distinguish between the box and the box prime, there will be no problem. Let's make it clearer by changing the exponent to half and rearranging the terms. How about that? 4 minus x squared is the box, and it looks like we need its derivative, which is minus 2x. So we multiply negative 2 in front of x and divide the same value in front of the integral sign. Now let's bring in the box rule and fill in the blanks. We put 4 minus x squared in the green box and minus 2x in the box prime. Then, as mentioned earlier, we divided negative 2 in front of the integral sign to cancel out the negative 2 in front of the x. We also multiply the right-hand side answer by negative half. Put 4 minus x squared in the green box, add 1 to the exponent to get half plus 1, and put the value back in the denominator. Let's also add the constant of integration, c. To simplify further, we can write it like this. And when we multiply 2 and 3 over 2 in the denominator, we get 3. So the answer is like this. It looks like the e at the top. This problem has a square root in the denominator, which is not much different from the previous problem. Let's try to move the terms in the denominator to the numerator using negative exponents. It will become 3x squared plus 5 to the power of negative half. And doesn't the x right after it looks like it could be the box prime? Let's apply the box rule by substituting 3x squared plus 5 into the green box, and its derivative is 6x into the box prime. However, there seems to be a problem, as 6 is not visible in the problem. Since we cannot simply multiply by 6, let's divide the entire equation by 6. Don't forget to divide the right answer by 6 as well. Let's put 3x squared plus 5 in the green box, negative half plus 1 in the exponent and denominator, and add c. The exponent and denominator will each become 1 half, and the product of 6 and a half in the denominator will become 3. Therefore, the answer can be written simply as this, which is the same as D. We have a trigonometric function here. But do you know what to do with the square root in the denominator? Yes, you need to bring it up. So it becomes 1 plus sine theta to the power of negative half. And would it be great if the cosine theta right after it becomes the box prime? Let's use the box rule and put 1 plus sine theta in the green box and its derivative term cosine theta, which is right above it, in the box prime. We have a definite integration, and we need to find the value from 0 to pi over 2. We can simplify the expression in the green box of the right answer by substituting 1 plus sine theta in the numerator and negative half plus 1 in the exponent and denominator. Now we can evaluate the integral by plugging pi over 2 and 0 for the theta and subtracting the values. Since sine pi over 2 is 1 and sine 0 is 0, the result will be 2 times square root 2 minus 1. This answer is D in the given options. Let's move on to the next problem. This problem seems quite easy. Let's try to find the answer quickly in just 2 lines without using use substitution or expanding the terms. We will use the box rule and put 3x minus 2 in the green box and 3, which is the differentiated term, in the box prime. We need to divide by 3 again, just like before. We also need to multiply the answer on the right by 1/3. In the green box, we put 3x minus 2 again, and the exponent and denominator becomes 2 plus 1. We simplify the expression a bit and plug in the values. The denominator becomes 9 since it is 3 times 3. When you plug in 1, we get 1, and when you plug in 0, we get -8. Add these values and divide it by 9, which gives us neat answer of 1. Therefore, the answer is D. This problem is also straightforward. Let's first rearrange the terms and apply the box rule. We put x squared plus 2 into the green box and its differentiated term 2x into the box prime. However, in the given expression, we don't see the number 2. Therefore, we will divide the entire expression by 2 before applying the box rule. Also, make sure to divide the right-hand side answer by 2 as well. Now, let's substitute x squared plus 2 into the green box and fill in the exponent and denominator with 2 plus 1. Simplifying the expression, we get 1/6 times x squared plus 2 to the power of 3. Substituting 0 and 2 into this expression gives 27 and 8 respectively. So the final answer is 19/6, which corresponds to option D. Do you see what we need to do now? Most of the problems are designed to apply the box rule effectively. In this beautifully designed problem from the past paper, the box and the box prime are clearly visible. Bring the denominator up as a negative exponent and write 3x squared at the end. Then x cubed plus 1 becomes the green box and the exponent remains negative half. And its derivative 3x squared goes into the box prime. As for the right-hand answer, x cubed plus 1 simply goes into the green box, and the exponent and denominator becomes negative half plus 1 with c added. The exponent and denominator becomes half when I calculate it, and the final answer is 2 square root x cubed plus 1 plus c, which looks like option A. With a little practice, you can even find the answer through mental calculation. This problem is similar to the one we solved earlier, isn't it? Yes, that's right. As I gathered, only integration problems from the past AP Calculus AB and BC exams, there are similar types of problems. Let's solve it quickly as a review. Again, we'll bring the denominator up to x squared plus 9 to the power of negative half. Put x squared plus 9 in the green box, and the exponent will be negative half. Finally, we put the derivative of x squared plus 9, which is 2x, in the box prime. Since 2 is not visible in this equation as well, we'll divide the equation by 2. Then the right answer is multiplied by half, and x squared plus 9 is placed in the green box, while the exponent and denominator are negative half plus 1. Quick calculation, we can simplify the equation so that the exponent and denominator becomes half, and we can multiply to the denominator by half to make it 1. If we substitute 4 and 0, the answer is 2. The answer is D. It is interesting that the answer D appears quite frequently in these integration problems of the AP Calculus MCQs. This problem is a bit different. It asks for the value of f of 9 given the differentiated form of f of x. Let's take a closer look. As always, we'll rearrange the order of terms to apply the box rule. Value of this integral is f of 9 minus f of 1, where the problem states that f of 1 is 0. So we need to evaluate the integral to find f of 9. We'll use the box rule, putting ln x in the green box and setting the exponent to 3, and putting its derivative of 1/x in the box prime. This problem has a great shape for using the box rule. Now let's put ln x in the right green box with the exponent and denominator set to 3 plus 1. Substituting 9 and 1 into the simplified expression gives 1/4 times ln 9 to the power of 4, and using a calculator we get the answer of 5.826903. Therefore, the answer is C. This is the final problem for the basic box rule. Can you see the answer already? Let's go for it. We'll put x cubed plus 5 in the green box and adjust the exponent to 6 and put 3x squared, the derivative of x cubed plus 5, in the box prime. As there's no 3 in the equation above, we'll divide the entire equation by 3. We'll also divide the answer on the right by 3 and put x cubed plus 5 in the green box, and fill the exponent and denominator with a 6 plus 1. We're almost done. The simplified answer is 1 over 21 times x cubed plus 5 to the power of 7 plus c. So the answer is E. In this problem, let's see how to use the box rule in the integration of fractions. First of all, when a fraction appears, we must always check whether the numerator is a differentiated form of the denominator. If so, we can quickly find the answer using ln box, so it can be really effective. In this case, since cosine x in the numerator is a differentiated form of sine x in the denominator, let's put sine x in the green box and cosine x in the box prime to quickly find the answer. Then sine x will also be inserted into the green box on the right side, and now we just need to find the value. If we substitute pi over 2 and pi over 4 into sine x, we need to know these special angles, which I assume you all have memorized. If you're still confused, I will show you the easiest way to memorize the special angles of trigonometric functions in my next video, which I will upload in a few days. Sine pi over 2 is 1, sine pi over 4 is square root 2 over 2. Since ln 1 is 0, only the second term remains, but the answer doesn't look nice. We need to modify the form a bit with some algebra. If we move the minus sign in front of the log inside, we can create a reciprocal, and by rationalizing the denominator of that reciprocal, it becomes ln 2 square root 2 over 2, which ultimately simplifies to ln square root 2. And the answer is A. This problem is not a fraction, just tangent to x. However, tangent to x can be expressed as sine 2x over cosine 2x, so it can be written as a fraction. If we differentiate the denominator, a shape similar to the numerator will come out, right? So let's use the box rule. First, we put cosine 2x in the green box, and its derivative of minus sine 2x in the box prime. Since the original problem didn't have the negative 2 multiplied, we'll divide it by minus 2. We'll also divide the right answer by negative 2 and fill the green box with the cosine 2x. The answer is B. Another fraction problem. Box rule comes into play again. We put x squared plus 2x in the green box and its derivative 2x plus 2 in the box prime. As a result, the numerator becomes twice the original problem. Simply enough, just divide it by 2. After dividing the right side by 2 as well, we plug 2 and 1 into the expression in the green box. The answer ends up being half times ln 8 minus ln 3. What's the answer? It is B. The problem is similar to the previous one, right? Let's solve it simply. Let's put x squared plus 1 in the green box of the denominator and put its derivative 2x in the box prime. Then we divided the formula by 2. We also divided the right answer by 2 and put x squared plus 1 in the green box, and then substitute 3 and 2 respectively. The answer is 1 half times ln 10 minus ln 5, which ultimately becomes 1 half ln 2. So the answer is B. Shall we quickly solve this problem too? Let's put x squared minus 4 in the green box of the denominator and 2x, which is derivative of the x squared minus 4, in the box prime of the numerator, and then divide the entire expression by 2. Now I'm sure everyone understands why we divide it by 2. After dividing the right hand side by 2, we put x squared minus 4 in the green box and choose C as the answer. The denominator is linear this time. What happens when you differentiate the denominator? That's right, we get negative 3. So if we have a negative 3 in the numerator, we can solve this problem. Let's put 5 minus 3x in the green box and negative 3 in the box prime, and divide both sides by negative 3. We also fill the green box on the right hand side with the 5 minus 3x and calculate the definite integral. When we plug in 4 and 2, we get ln 7 minus ln 1, and the final answer is negative ln 7 over 3. Therefore, the answer is B. This problem is similar to the previous one. Let's do some mental math first. Since the derivative of the denominator is 2, we can multiply the numerator by 2 and divide the entire expression by 2. Then the integrated answer will be half times ln 2x plus 1. Now, if we plug in 2 and 1, we'll get the answer E. Now let's try using the box rule in exponential functions. If you see an exponential function in the problem, try applying this box rule first. Representing the fraction in this way make it easy to identify who the box is and who the box prime is. The green box is negative x cubed, and its derivative, negative 3x squared, goes into the box prime. Since negative 3 was multiplied, we divided by negative 3 again. We also divided the right side by negative 3 and fill the green box with negative x cubed. There doesn't seem to be a similar answer, so let's try moving the exponential function to the denominator and eliminating the negative sign. Then the answer looks like C. In this problem, let's apply the box rule for exponential functions by rearranging the order of terms. The green box should contain x squared plus 2x, and the box prime should contain 2x plus 2. As you can see, the original expression has doubled. All we need to do is divide the expression by 2. We divided the right side expression by 2 as well. Fill the green box with x squared plus 2x and calculate the definite integral. Simplifying the answer is e to the power of 3 minus 1 over 2, so the answer is B. This problem also seems like the answer will be immediately apparent if you just rearrange the terms. X to the power of 4 goes in the green box and its derivative for x cubed goes in the box prime. Of course, since we have introduced the previously absent multiplication by 4, we'll divide by 4 to get the same value. We'll also divide the right side by 4 and fill the green box with the x to the power of 4. Since this is a definite integral, we can evaluate it by plugging in 1 and 0 for x and calculating the value. The answer simplifies to 1 over 4 e minus 1, so the answer is A. This problem has a peculiar factor of 1 over 2 in front. Shall we move it behind e? Do you see the box prime now? Yes, that's right. If you put t over 2 in the green box, the next term half becomes the box prime. I like this problem. Therefore, the answer is simply e to the power of t over 2 plus c, which is option C. Let's try changing the order of the terms in the problem as well. Let's put x squared in the green box and its derivative to x in the box prime. Now, naturally, you will multiply the entire equation by half. Do the same for the right side. Finally, fill the green box with x squared, and the answer will be A. In this problem, even though the expression looks like a fraction, differentiating the denominator will not yield the numerator. If it did, we would have used the box rule for fractions. Since we see an exponential function, let's start by rewriting the denominator as secant square x by bringing its terms up as reciprocals. If we put tangent x in the green box and its derivative, secant square x becomes a box prime. Now, for the right answer, we just need to substitute the values into e to the power of tangent x. Tangent pi over 4 is 1 and tangent 0 is 0. So the answer is e minus 1, which is option C. Let's take a look at the first example problem involving the sine and cosine functions. Apply the box rule for sine. We can put 2x plus 3 into the green box and its derivative 2 into the box prime. Since we now have an extra 2 in the equation, we need to divide it by 2 to put the expression back into the original. Therefore, the answer simplifies to negative half times cosine 2x plus 3 plus c, which is option D. This problem is also simple. Let's put 3x into the green box and 3 into the box prime. Remember to divide the result by 3 before moving on. Of course, we need to multiply the right side by 1/3 and put 3x in the green box to prepare for the definite integration calculation. Since the interval is from 0 to pi over 3, if we plug in each value, we get cosine pi and cosine 0. And since cosine pi is negative 1 and cosine 0 is 1, the answer is simply 2/3. So the answer is D. Let's solve a cosine problem this time. The box rule for cosine is as follows. Now let's fill in the green box and the box prime. When you put 2x in the green box and 2 in the box prime, and then divide the whole equation by 2 to finish the left-hand side calculation. Now let's find the answer on the right-hand side. We multiply by half and put 2x in the box, And when we check the options, we can see that the answer is C. Shall we try changing the order of these terms? Let's apply the box rule. Put x cubed in the green box and put its derivative 3x squared in the box prime. Remember to divide it by 3 to get the original expression back. To find the answer on the right, we simply multiply by 1/3, put x cubed in the box, and add C. Looks like the answer is B. This is the last problem for today. What method should we try? How about using the basic box rule? Who will go into the green box? Then who will becomes the box prime? It will be 2x that becomes the box prime. But in the problem, there's no 2x. Can you multiply by 2x and then divide it by 2x again? Absolutely not. X cannot come out of the integral sign like that. Only constants and terms unrelated to x can freely come out. So we have no choice but to expand the expression, and the expanded expression is x to the power 4 plus 2x squared plus 1. Integrating each term, the answer is x to the power 5 over 5 plus 2x cubed over 3 plus c. So the answer is E. Today we solved many MCQ problems using the box rule and learned that it efficiently and quickly finds the answers. In fact, the box rule that I introduced is not a new rule. It is a method of reducing the steps by omitting the use substitution step and solving the problem through the inverse process of differentiation. People who have solved a lot of calculus problems can empirically understand this fact. In order to explain it more easily and simply to students, I brought in a box and organized the shape that fills it, which resulted in this shape and was simply called the box rule. I have introduced the integration using the box rule so far, and I will also introduce differentiation using the box rule in the future. Also, all the formulas used are uploaded on my community tab on my YouTube channel, so please feel free to download them. That concludes today's video, and I will see you again with the better videos. This has been your Math Guardian, Alex.